So, we are going to have our last chapter today. So, we looked at the entire welding processes, characteristics, physics, so whatever we can use, and we did not skip much of them, and we covered as much as we could do in during this time frame. So, today we are going to look at some of the terms we use in welding fraternity. Okay, so this is also very important. So, especially you are employed in a fabrication unit or in where welding is the major manufacturing process. So, these terms you will have to be familiarized with, right? And we look at some of them. So, the common terminology I am going to talk about, like HAZ for example. Okay, so these are all very simple terms which you are expected to know. Or I mean, when you are attending in the welding metallurgy for example, then you will know all these metallurgical terms which are associated with welding. So, what you are going to learn this is more of a process related terms, okay, or the joint design related terms. So, we look at it and then we will wind up this class, right. Okay, so, the first thing when you look at the weld itself, so you make various names we say, like for example butt joint. Okay, so when do you call it a butt joint? So, butt joint when you are joining it either two flat surfaces, or you have a joint where the plate thickness is exactly perpendicular to the weld center line. Okay, so for example, you make a butt joint. So, this is butt joint with V groove, isn't it? So, the butt joint when you do it, you join two flat surfaces, right. So, these joints are known as butt joints, right, and you can make as the joint design based on the need and then geometry you need. We will see in subsequent slides what are the joining bevels that are possible and that we commonly used to make butt joints. Okay. So, this machining at the interface is known as bevel, okay, and bevel can be V or K or double V. Okay. So, various angles we can use, again we will see in the subsequent lectures. Okay, so, the butt joint is clear, right, and then fillet joint. So, fillet joint generally we use the term fillet joints when the weld center line and the thickness they are not exactly perpendicular, and say for example, in this case the weld center line and the thickness and the surface they are all coplanar, isn't it? Weld thickness, the weld and weld center line exactly perpendicular in butt joint, whereas in a fillet joint, so we make joints for example in overlap configuration. So, this is an overlap joint where so you make the weld using a fillet, isn't it, something like this. So, in overlap configuration, or you can also do in T configuration. For example, you can also do T joint. Okay, so you can also do joints in T configuration and with a fillet. So, fillet means you add an extra material, extra layer to make a joint. Okay, in butt joint you are filling the weld cavities using the filler, or in autogenous weld you can also melt and then fill the cavity, whereas in fillet joint you always have an extra material joint. So, in this case it is an overlap configuration, isn't it. Similarly, in T weld you can also make a fillet joint, isn't it. So, in T joint it is even more clear if you look at say this picture. So, this is what is a joint? This is T joint with fillet weld, isn't it. So, in fillet weld, so we make a fillet, fill and then make a joint in T configuration. So, in fillet weld, when in fillet welds there are some other terms you need to remember. See, in both in fillet weld, even in butt joint, say butt joint also, okay, and this region is known as root. Okay. In fillet weld, this is the root. So, when you are doing multi pass welds, we always do root pass fast with very carefully controlled welding procedures, because root pass make sure that the first interface is connected without much of distortion and without inducing crack, for example hard cracks during welding. So, root pass, for example, if you are doing in a multi-pass weld in critical welds, root pass is always done with GTAW in root pass, okay, the first pass to fill the root cavity, right, and these regions are known as toe. Okay, these are toe regions, right. So, similarly here this is root, these regions are toes. The toe regions are extremely critical in terms of subsequent mechanical properties of the weld, because so when you are depositing a multi-pass fillers, so you end up always finishing either this side or this side, isn't it? So, if you are not doing the multi-pass welds and the weld cavities filled properly, these toe regions you may always have a notch formation. Okay. Say for example, you have a magnified view. So, and you are filling it something like this, and this is your weld. So, you see that, so when you are not properly filling it up, or your the pass is not sufficiently wetting the weld cavity, for example, then you always have a notch formation on weld toe. And the toe region is the region at which you finish the weld at the end. So, the tensile stresses, they are always present at the toe regions. Okay. So, toe regions would always contain high magnitude of tensile stresses. So, with the presence of the toe notch and the tensile stresses, you always see that when the weld is subjected to mechanical loading in cyclic loading, there is a possibility of crack nucleation from the toe region and subsequently it will progress. Okay. So, if you look at the component failure in the weld by fatigue loading, and if the weld is not treated properly, if the weld is not done properly, you can always see a crack propagating from the toe region towards weld center line. So, the moment you identify there is a crack nucleated at the weld toe and subsequently progress, you can always conclude that fatigue could be an issue, fatigue loading could be an issue, because so the notch act as a crack nucleation site and subsequently the presence of tensile stresses at the toe initiate the crack and subsequently the crack can propagate. So, not only fatigue, so this region because of the high tensile regions, and we also have a dissimilar material, isn't it. So, this is the base material, this is the weld. So, there could be some compositional mismatch, and that can also act as a corrosion initiation regions, because we have two material. So, we may also activate the corrosion at the toe regions. Okay. So, it is very important to know what is toe, and we will not go in detail about the stress development, and because we are going to look at in welding metallurgy. So, but the terminology you should be very familiarized with. The toe regions is the region which actually there in the weld face which actually connects the weld fusion zone with the heat affected zone, the region toe. Right, is clear? Okay. So, in the T joint also you have the same, and butt joint also you will have see these regions, root, toes, and this is the weld face. It's clear? Good. So, and then some more terminology, so you need to remember. For example, the in a T joint with fillet, or any fillet weld. So, the length L is leg length. Okay. So, the distance between the toe and to the preer interface. Okay. So, this region, the region from the toe to until the preer interface point is the distance is known as leg length. Okay. Similarly, the thickness, the distance between these regions, okay, in the convex fillet and in concave fillet, the distance between these two regions is known as throat thickness. And this throat thickness is extremely important, similarly leg length as well, because that is going to determine the amount of passes you need to make to achieve a required mechanical properties of this joint. Okay. So, if the throat thickness and leg length is smaller, and you may not have a strong weld, because if the thickness is higher, the base metal thickness is higher, and you need to, if you are not matching the thickness with the throat thickness and the leg length, and you may have a stress partitioning, stress concentration at the fillet, which may lead to as failure. Okay. So, this throat thickness and leg length is determined by your base material thickness and nature of the base material what you are going to use, plus the load which is going to be subjected in the weld. Yes, it's clear? Any questions so far? So these kind of joints, the T joints, the fillets, very commonly used for the constructions, bridges for example, shipbuilding, structures. So if you look at the civil constructions, okay, so the pillars, the steel pillars and bars, they are all welded in T configuration with fillets. Okay. So based on the thickness of the plates and the load bearing capacity and the load which is going to be subjected during the commercial operations, so we will have to make sure that now we have calculated the throat thickness and length properly. Right? It's clear? Good. So and then bevel terminology. So what is bevel? Again, bevel is machining. So how you machine the interfaces. Okay. So what is important when you are mentioning say that I want to make a bevel at the interface, the important factors are, the first is the included angle or the bevel angle. Okay. So bevel angle is this angle, the angle between the weld center line with the surface. So included angle includes the both angles, and that is included angle. Okay. So for example, this top side is a toe side and this is root side. So when you are making bevel, you always, as I said, the first is the root pass, right? And the root pass, when you are making it, we also make some root face for the root pass. So root face, the height and the length is known as a root gap width. Okay. And this is root face and this is root gap width or preset gap. Okay. Right. And these are joint faces, and the root pass fills the root face, and subsequently the conventional the additional passes fill the subsequent passes. So when you are welding a thicker sections, root pass is always we do it in a GTAW, and the remaining can be GMAW or FCAW or SMAW. Okay. So because the GTAW gives the very controlled depositions, right? It's clear? So this root side and top side. Any questions? Yes or no? Okay, move on. Okay. So what are joint designs? So the one thing I showed you already, the butt joint, right? This is square butt preparation. And butt joint, we can also have a bevels like single V, where you make a single V with an angle. Okay. And single V is generally done with this somewhat lesser thicknesses, but if thickness of the plate goes higher, and we can also go for double V. So why do you need double V? Because you can fill it both sides, right? So double V or K is also commonly used. So what is K? Is you have a double V in one side, the other side is flat, isn't it? So if you want to have a conventional K letter coming up, so you can also make this side flat, okay, and then you can make double V in one side. So this is K bevel. Okay. and K bevel and then double V bevels are used for thicker sections, so more than 20 mm or so. Okay. And reasonable cross sections, the V bevel is commonly used. Okay. So, there are disadvantages in terms of load distribution. In K bevel, you may also change the stress development and or segregation patterns in K bevel, whereas in V bevel you end up building stresses at the toe as well as weld segregation at the weld center line. Okay. And this is single U preparation. Okay. Single U preparation is basically basically you prepare with a slight elliptical grinding. Okay. So, this is T joint. So, T joints are done mostly with fillet. Okay. So, these kind of T joints you have a fillet made in both sides. Okay. And what is leg length? So, this is leg length and then this is your throat thickness. And this is lap assembly in overlap configuration. Again, in lap joint, if you are doing in a laser welding, you can also do in a spot, is not it? And you can also do in a linear. So, you can refer my previous slides on the joint design. And in conventional GMAW or GTLW with filler, so you always do with fillet joint. So, this is lap joint with fillet, right? It's clear. And this is with T joint with single J preparation, and this is also sometimes used. So, where you have a flat and then in this surface you make a J. So, this J bevel. Okay. So, J bevel means you make sort of a J at the interface. It's clear? Good. So, these are simple terminology I wanted to introduce, right. So, good. And then welding positions. How do you weld? So, you can either weld it in in down hand or up hand or side, and we define welding positions in two terminologies, and this is a more what you call layman term, welding positions. Like you can look at it by looking at the picture. For example, PA is a simple flat weld. You do it in a complete down hand. Okay, so you take a welding torch, or welding torch is mounted and plate is kept at the flat surface, and then you do down hand welding. Okay, and that is known as a flat. It's called PA. And PA, PB, these are all nomenclatures used by AWS. Okay, then PB is for fillet. Okay, so horizontal, vertical. Okay, because this is horizontal and this is vertical, isn't it? Okay, and then PC, if you are doing welding in an angle on the side, it's PC. Okay, and PD is horizontal but in overhead configuration over here. And then again the PE, PF, PG, they are all vertical, but you will be doing either like in this direction or the other directions, PF and PG. Okay, so yeah.
PF and PG,
yeah.
they are like this, right? And the PE is something like this.
Yeah. So, you will be doing it like that, or you will be doing it like this, like that. So, PF is overhead, you are doing like this, whereas in a PF, PG you are doing it like that. Yes, it's clear? Yes or no? Okay. And more defined terminology by International Institute of Welding, so we use to denote the welding positions by using G's and F's. Okay. So, the F denotes fillet weld, but the position, based on the position we can say 1F, 2F, 3F or 4F. So, what is 1F? So, 1F is a down hand weld, you make fillet. Okay. So, something like this. Okay. But 2F is done in horizontal position, the axis of weld is horizontal. Okay. So, in horizontal plate and vertical plate you do a welding fillet like this. So, that is 2F. right? It's clear. Whereas in this case, the throat is vertical, throat of the fillet is vertical. Okay, where here the axis of the weld is horizontal, the throat is an incline 45 degree. Okay. And vertical positions, if you are doing it like this, okay, so plates are like this and you do it like that. So that's 3F, and 4F is overget positions. So like this. So that's 4F, right? So these are for fillet wells. For groove wells, we use G terms. Okay, so G term is a simple 1G is very simple. In flat plates, you do in downhand welding. The most of the cases we do it in laboratories. No 1G, so you make a groove and then deposit. So that's 1G. And you can also do it in a circular geometry. So in this case, welding of pipe. When the pipe is rotating, okay, so you have a pipe, your torch is fixed. Okay, so when the pipe is rotating, that's also 1G. Okay, either you can have a flat plate and then you fix the torch and whether plate can move or torch can move, that's also 1G. Or you can have a pipe, the torch is fixed and the pipe is rotating and you are filling the groove, that's also 1G, right. So that's 1G. 2G is you keep the plate vertical and then do a weld in these configurations. Okay. So the plate and the torch is 90 degree in this way, right. So this is 2G, right. The same can be done for pipe also. When a pipe is rotating vertically and then you weld. So pipe is rotating and then you keep the torch stationary and then rotate the pipe, right. So that's 2G. It's clear?
Even the welder going around is also 2G?
No, if a welder going around, that's 5G. Okay. If a torch is fixed, either pipe is rotating, okay, or you keep the plate constant, okay, and then you move the plate either or the torch, that's still 2G only. Okay. When the torch is moving around the stationary pipe, okay, or basically torch means welder has to go, okay, so that's 5G. Okay, so the pipe is not rotating. So 5G configuration you can easily imagine, it's used for welding long distance pipes. For example, if you want to do an offshore pipes welded and then laid onto the sea bottom, how do you rotate the pipe? Isn't it? It's not possible because the pipe length it can be several thousand kilometers. Okay, you cannot rotate the pipe. Only the welder has to rotate or the torch has to rotate, isn't it? So that welding is very challenging because in a single welding operations, you also change the metal transfer characteristics, isn't it? So gravity changes. So you keep it like this, the pipe is there, and then you start from here. Generally we start from here because that's easy. Gravity assist metal transfer. But when you change, you are going around, isn't it? So the entire metal transfer characteristic can change. So remember, what are the forces that assist the transfer? Gravity assists only in downhand welding. So if you are changing the positions, you also change the forces that assist and detect the metal droplets. So when you are doing 5G welds, you have to make sure that you adapt the welding procedure such a way that your metal transfer is uniform along the circumference when you are welding, isn't it? So your welding program should be adaptive as a function of the position, so that you don't change the droplet transfer frequency as well as transfer behavior, because the balancing forces are always changing, isn't it? So that's why welding in 5G configuration is the most challenging.
So, but if the pipe is vertical and he is doing like this, then
It's still 5G.
still 5G.
Still 5G. Okay, so your pipe is vertical, and if you are going around, it is still 5G, because the forces are anyway changing.
Oh, sir, the gravity is always downwards.
Yeah,
As it is going horizontal.
Yeah, but the surface tension can change, okay, because you are also changing the plasma jet, right, with respect to the height and position. Good. It's clear? So, and then 3G is the flat is, yeah, pipe is, so if a plate is like this, and then you are welding it, right. So, that is 3G, and if you are keeping like this and you are welding like that, that is 2G, isn't it? 3G is more complex than 2G, isn't it? So, 3G you are doing a vertical welding, right, whereas in 2G positions you are doing horizontal welding. So, you are not changing the height, the distance. So, torch is constant and then it is moving. Now, if you are doing the vertical movement, again the force balances can be different, because you are changing the height. Okay. So, the most complex the welding procedure is 5G and then 3G, so where you have a flat plate doing and vertical welding. And there are even more complex, which are generally not advisable to do, is in a complete overhead welding. Okay. So, that something like this you do weld in a plate's horizontal positions. Okay. So, that is 4G. Okay. So, this and yeah, practically it is very difficult to do a welding in one configuration is 6G position, and it is extremely challenging, where the pipe is rotating an inclined angle. Sorry, when the torch is rotating an inclined angle, pipe is kept in inclined, something like this. Okay. So, you go around, do the weld on inclined pipe. Okay. So, material fluid flow behavior, the transfer behavior, everything would change. So, when the pipe is kept really at an angle, and then the welding is done in orbital manner, where the welder or the torch goes around and do the welding. So, that is 6G. Okay. So, 6G welding is generally done with an extremely trained operators, because you will have to make sure that when you are depositing you have welding procedures adjusted for each position as well as each pass, because you need to make sure that when you are depositing the weld should flow and then you form the fillet and without any defects, for example undercuts or overlaps, right. It is clear? Any questions so far? Okay. So, groove weld 1G is flat down and welding, 2G is horizontal welding, but plates kept vertical. Okay. 3G is plate kept vertical, but you do weld also vertically. Okay. 4G is in a flat plate, a complete overhead welding. Okay. So, it is 4G. Then 1G in pipe is very simple, the groove weld, the pipe is rotated, it is very easy. So, when the pipe is rotated, pipe can be rotated and then torch can be stationary. And then 2G is the pipe is kept vertical, okay, still pipe is rotated, reasonable, is not it, right. And then 5G, so 5G is pipe is horizontal, but torch is rotated, right. Is clear? 6G is pipe is stationary, but with an angle, still the torch is rotated around. Is clear? Any questions? Good. So, then we will wind up. Okay, I hope you enjoyed the classes, right. So, We'll see you next time.